Today we began today's lesson with the discussion of mysteries and clues. So if you've ever watched anything like Law and Order or any of those detective shows, you have the detective, right? And a detective looks at a bunch of different clues in order to determine how to solve a crime. So just like this detective, we're going to look at clues given from a figure in order to determine which strategy we will use to solve the triangle. So if we examine these three clues in order to solve triangles, we can see which one is different from each one. So in the Pythagorean theorem, we use the Pythagorean theorem when we are given two sides and a problem is asking for the third side. We use special triangles when we're given one side and one special angle. A special angle is 45, 30, or 60 degrees. And they ask us to solve for a side. And we use trigonometric ratios when we're given one side and one weird angle. So if you're given an angle that's labeled anything other than 30, 45, or 60, let's say the angle is 28 degrees, we know we're going to use trigonometric ratios. And the thing that they all have in common is that you can only solve right triangles with these three strategies. So let's look at the first example. Look at the picture up here. We have a right triangle here. And we see that this side is 34, this side is 22, and this side is x. Now, isolate one triangle and ignore the other part. This will help you solve the triangle easier. Now we see that the problem gives us two sides. If we look at our clues over here, we can see that when we are given two sides, we should use the Pythagorean theorem to solve the triangle. So we're going to use the Pythagorean theorem because the problem gives us two sides. So let's put the formula over here. We get c squared equals a squared plus b squared. Let's find c. C is always the side across from the right angle, also known as the hypotenuse. So x squared equals, this side will be a, this side will be b. 22 squared plus 34 squared. And we get x squared equals, and we get 484 plus 1,156. X squared equals 1640. Square root both sides, and we get x equals 40.49. Or 40.5. Let's look at another example. In this problem here, they tell us to find x using the figure. So we're going to do the exact same thing we did last time. Let's pick one triangle. Let's pick this one here. And we're going to isolate this triangle and ignore this triangle. So the problem tells us that this whole side here is 42. So we're going to divide it by 2 in order to get this part here, which gives us 21. So now we have one side here and one side here. So the problem gives us two sides as our information. If we come over here and look at the clues, we see two sides here. Therefore, we're going to use the Pythagorean theorem to solve. So we get
So are you using cosine? No, you have, why do you put adjacent here?
So we have to find C first. C is across from the right angle. And we get A here and B here. 24 squared equals 576. 21 squared equals 441 plus x squared. Subtract 441 from each side. We get x squared equals 135. Square root both sides. X equals 11.6. So in this one, we use the Pythagorean theorem because they gave us two sides and they needed to find the third. Let's try this problem here. So it says find x using the figure. The figure they give us here is a square. Remember when we first explained special triangles? And the 45 special triangle started from a square. We drew a diagonal here, and we found that the sides across from 45 degrees were x, and the side across from 90 was x square root of 2. So we put that information into the figure, and we see that this here is going to become our equation. So over here we get 10 equals x times the square root of 2. We have one special angle and one side. We are going to use the 45, 90 triangle. Let's solve for x. We find that x equals 5 times the square root of 2. We put it into the figure here. And we get x equals 5 square root of 2. So we used special triangles in this instance because they gave us a square that makes a 45, 90 triangle. So they gave us one special angle and one side. Let's try this example now. So in this one here, they give us an angle here, and it's not a special angle, and they give us one side. So if I look at my clues, is there one that gives us a weird angle on one side? Yep, this one here. We're going to use trigonometric ratios to solve this problem. So let's begin. We always label the sides according to the angles. So the side across from 90 degrees is the hypotenuse. The side across from the reference angle is the opposite side. And the side adjacent to the reference angle is the adjacent side. So now I look for the sides where they give me information. They give me information here. And they give me information here. So I'm going to use AH. I write my acronym. And I look for AH. AH here, I'm going to use cosine. So I write cosine of 64 degrees is equal to adjacent over hypotenuse. I get the cosine of 64 equals the adjacent side is 15, the hypotenuse is x. I have to get rid of my fraction. I get x cosine of 64 equals 15. Divide both sides by the cosine of 64. Divide by the cosine of 64. And I get
Now, step 2 is
38.3. So the method I used was trig ratios because I had one side given, and one weird angle given. So, in summary, we look for the clue given the figure, and then we pick which strategy we will use to solve the triangle.